So this is part 3 of the NMR notes. Now that we've talked about using the chemical shifts and kind of the height of the peak to kind of figure out what we have, we now need to go into where it gets a little more tricky. And that is what we call the N+1 rule. Okay, so find this part of the packet. And what I'm going to talk about is the fact that the signals that we were just looking at do what we call a splitting because of the fact that the hydrogens influence their neighboring hydrogens. So write down N+1 rule. N stands for the number of hydrogens attached to the next door carbon. And I will go through a few examples of it with you. What happens is because there is a neighboring hydrogen, it's going to essentially influence that hydrogen, and so it's going to what we call split the signal into multiple peaks. So this rule will make a lot more sense when we do a couple examples to kind of go through it. So flip to the next page, and you're probably going to need 2 colors, a pen or something like that to kind of show. So I'm going to highlight essentially the hydrogens that are over here on the right. I'm going to go through each one of these to kind of explain what is taking place. So if I am looking, and you are always in NMR land talking about you are the hydrogen. So you are the hydrogen on this carbon. What you are looking at is your next door neighbor. So the next door carbon. You are looking to see if it has any hydrogens attached. And this carbon in particular has no hydrogens attached. So that means if I am doing the N+1 rule, N is 0, plus 1 is 1. So that means I produce a singlet, okay? So that means it tells me something about the structure of that carbon molecule. So the second example here, this is my neighboring carbon. So I'm going to color this a different color. I have one hydrogen that is on my neighbor, okay? So that's going to be my N. So this is my N. So I have a 1 plus 1 is 2. So what happens is this hydrogen that I have highlighted in yellow splits into what we call a doublet, okay? It's not the orange hydrogen we're talking about. We're talking about this hydrogen here. So if you are that hydrogen, your neighbor has one hydrogen attached, you're going to split into a doublet. Then again, next example, my next door neighbor has 2 hydrogens attached, okay? So I am this hydrogen, the yellow hydrogen. So what it does is split into what we call a triplet. Now a triplet is 3 peaks, but you will notice that the middle peak is higher than the 2 next to it, and that's pretty characteristic of what we call a triplet. And finally, the last example is I have 3 hydrogens on my next door neighbor, okay? So 3 plus 1 is equal to 4, so it splits into what we call a quartet, okay? I'm going to go back to this previous example and write it down. So N plus 1, 2 plus 1 equals 3, so I get my triplet, okay? And you could get more splitting patterns than just a quartet because you could have carbons on either side. So for example, if this is my hydrogen that I'm looking at, and I have carbons with hydrogens on either end, okay, and I am this particular hydrogen, okay, you realize that my splitting pattern is then going to be affected by my 2 neighbors here, okay? It is never the hydrogen that is on that same carbon. You're always looking at the next door neighbors. You're always looking at the next door neighbors. So this is called Pascal's triangle to kind of get you to understand how this all splits. And then the last picture here, so kind of the same idea. Again, you are the, it's more bolded, and I know maybe in your notes it may not come out that well, but you are this hydrogen, so you are the one generating this signal. But because it splits to a doublet, it's because of the neighbor is this one. I have 2 hydrogens on this neighbor, so I have this, and then I have neighbor, neighbor, So then it keeps splitting off of that, okay? So, all right, so let me explain this a little bit more to you by doing an example with you, okay? So flip to the back of this packet and just draw this in on the blank page that you have there. So draw the ester I originally drew at the beginning of this lecture. So draw a carbon, so it's a total of 4 carbons, but you have 1 carbon over here with 3 hydrogens. You have an oxygen, then you have a carbon with 2 hydrogens, and you have a carbon with 3 hydrogens. So what we're going to do with this discussion is I'm going to need my shifts, okay? I'm going to need my shifts, and I'm going to essentially draw the NMR underneath it. So I'm going to start with 0 over here on the right. And because I know what peaks I'm looking for, we're just going to go 1 through 4, okay? And again, when you're doing, this is going to be the second step when we start to do NMR packets or practice for you to draw them because it's a little more tricky. Instead, this is just trying to emphasize the idea of splitting, So you need 3 different colors. Because essentially these hydrogens here are going to see one environment. This hydrogens is directly attached to the oxygen end of the ester is going to see another environment. And then these hydrogens on the end. So I'm going to color in the one on the end. So I have 3 hydrogens there, 3 hydrogens there. Now typically anytime I have what we call a CH3 off of the end of a molecule, it's going to be around a 0.9. So I'm going to draw this somewhere around the 1. And what I have to look at is how am I going to actually draw it in terms of what is the splitting pattern going to be. So these hydrogens that I have circled in orange here, this is my only neighbor, okay? My neighbor carbon here has how many hydrogens on it? It has 2 hydrogens, okay? So since it has 2 hydrogens, my n+1 will is 2 + 1 is 3. So this is going to be what we call a triplet. Okay, and it's going to be around 0.1. Okay, so I'm drawing a triplet in that color so that you could see that that is going to be due to those 3 hydrogens. Okay, so that's my triplet. And when we're doing these drawings, and I'll emphasize this again, draw it, but then also put next to it what the splitting pattern is so that there's no misinterpretation when you do quizzes or tests for me that I know exactly what you're talking about. All right, so then I have these hydrogens there, okay, as one color. Let me see if I have another color here. And then I have these hydrogens here, okay. So I have to look at my ester groups on my chemical shifts, and I see that my hydrogens that are attached to the oxygen end are around 3.7 to 4.1, while the hydrogen that's on the C double bond O end is about 2 to 2.2. So I'm going to look at what I call my hydrogens over here that are on what I colored pink, okay? And I know they're going to be around 2.2 because they're right next to the C double bond O. Okay, so I'm going to draw it right here. So if I am the pink hydrogens, and again, you are always taking the perspective of that hydrogen. So if I look at my neighbor carbon, okay, so I'm not looking at the carbon itself and how many hydrogens I've attached. What I'm looking at is always the neighboring carbon. So here's my neighbor carbon. Do I have any hydrogens here? No. So n+1 rule is 0 + 1 is 1. So I'm going to have a singlet. Okay, and it is due to my pink hydrogens over there. Okay, now the height is going to be dependent upon, there's 3 there, so the height of the triplet would equal essentially the height of the singlet here in terms of the area. Okay, but again, how you draw it is not going to be as critical, but if that does confuse you, I just want to make sure that you understand that. And finally, my yellow hydrogens. Okay, again, these are going to be off of the oxygen end of the ester. So it's going to be between 3.7 and 4.1. So I'm going to go somewhere over here, okay? And I'm going to draw the yellow hydrogens, okay? So who are my neighbors? Well, on one side is the oxygen. On the other side is this carbon here. How many neighbors do I have on that carbon? Well, I have 3 hydrogens on that carbon. So 3 plus 1 is 4. So it's going to be a quartet. It's going to be a quartet. So quartets are going to be two peaks equal size in the middle, and then 2 peaks equal size on the sides, a little bit shorter than those middle peaks. Okay. And again, the height of this would be determined by, it has 2 versus 3. But again, I'm just trying to get you to understand what the splitting pattern is and where it would show up on